Yes. What is the answer you got? Did you try? See here. A is equal to density into volume into acceleration due to gravity. Because mg, upthrust is mg. M is rho into V. Okay. Minus. Next one is about the weight of the ball. So this is of water, this is of ball. Into density. Weight is of the ball is also not given, correct? Density of the ball is not given. So half of the density is given. See here. Solid ball of density, half that of water falls into. So half that of water it has to fall, they have given. Okay. Vg divided by mass. Can you help me for this? Can you help me for this? Correct? Now help me. How can we solve? It is given density of ball is half of the density of water. So rho W is 2 rho B. Vg minus rho B Vg divided by rho B Vg. Now what is the value? Rho B Vg. Therefore rho B 2 minus 1 is 1. Vg divided by rho B Vg. Sorry, here there is no g. This is mass, correct? Since it is only mass, no acceleration due to gravity, correct? Is equal to A. Rho B V get cancelled. So A is equal to G. Acceleration due to gravity is not with the what acceleration it comes down below the water is nothing but acceleration due to gravity itself. Since it is equal to acceleration due to gravity, with what height, from what height it comes, same height it will go. What do you say? What we have done? Force is equal to mass into acceleration. We want to find this height. Acceleration, with what acceleration if it goes, we can calculate, then we can calculate the height. Therefore, acceleration is equal to force by mass. Force is nothing but is on the upthrust due to water and weight of the ball. Upthrust due to the water minus weight divided by mass. So therefore, we know density is equal to mass by volume. In the place of mass, see upthrust is nothing but force. Again, it is a force due to the water. So rho W Vg minus weight of the ball. So rho V into G divided by rho V. This volume, how much volume it touches the water, same volume we will calculate. So V is same. 2 minus 1 is 1. So rho B V get cancelled. A is equal to G. Since acceleration, with the acceleration which is coming down is equal to acceleration due to gravity, how much height it has taken to reach the water, same height it will go down. So answer is B. Answer is B. Next. An ice cube of density 22. Ice cube of density 900 kg per meter cube is floating in water. We know the density of water is 1000. The percentage of the volume of the ice outside the water. Okay, you are going to put ice inside the water and some part of the ice is floating. So how much volume of the ice is floating, can be seen outside? And that is the question, correct? How can we calculate? Percentage of volume of ice outside is equal to density of water minus density of ice divided by density of water, fraction. Change in density. Since the density of water is more and ice is less, ice will float. So what is the change in their density? Divide by its density ratio of water ratio if we take, that will give you the volume of percentage volume. Means you have to multiply by 100. It will give you the percentage volume of outside the water, ice, how much is present. So density of water is 1000 minus 900 divided by 1000 into 100. 1000 minus 900 is 100 by 10. So answer is 10%. I can say 10% of ice can be seen outside the water. Therefore option C. Option C. What we have done? Density of ice and water they have given. You have to see how much it is outside. How much it is outside means the density of water is more than ice. So it is floating. So that what difference in the density divided by density of water, if we give fraction, then it is nothing but volume which is outside. Then next, water from a tap enters vertically down with an initial speed of 10 meter per second. Okay, initial speed is 10 meter per second. The cross sectional area of the tap is 10 to the power minus 4 meter square. Assume that the pressure is constant throughout the stream of the water and that the flow is steady. The cross sectional area of the stream 0.15 meter below the tap is. So you have to calculate area below the tap. Question number 23. If this is the tap, water is coming out. .15 meter down, what is the area of cross section? You have to find out. Stream of the stream below the tap. Okay, this area of cross section you have to calculate. How can we calculate area of cross section now? As it is coming from water, I can say decrease in potential energy. We are leaving the tap. Earlier there was potential energy. Now we are just opening the tap. So decrease in potential energy should be equal to increase in kinetic energy. What do you say? Decrease in potential energy should be equal to increase in kinetic energy. So therefore, what is the potential energy formula? Rho GH. Okay, correct. And potential energy is, kinetic energy is half rho V square. Now finally it will reach here. So it will be final velocity minus initial velocity. If we do this difference, then we will get increase in kinetic energy. Okay. So rho GH, I can say rho is common by 2 Vf square minus Vi square is equal to rho GH Rho gets cancelled. So what is remaining here is VF square is equal to VI square. VI coming this side, plus it will become plus 2GH. What is the height it is given earlier? Height is 0.15. So VI, initial velocity is how much? 0. Initial velocity is 0. 2 into 9.8. Correct? Calculate. Try to solve. Initial speed is 10, that is given. So 10 square plus 2, 9.8 into 0.15. What is the answer we get? 100 plus 3 into 9.8. What is the answer we get? VF is equal to 2. We get VF is equal to 2 meter per second. VF is equal to 2 meter per second. According to equation of continuity, we set AV or VA is equal to constant. So I can say V1 A1 is equal to V2 A2. So what I can say, the question, see here, what they have said here, pressure is constant and flow is steady. The cross-sectional area of the stream below 0.15, what I can say the answer? As velocity is 2 times, see here, earlier velocity was 10, now it is 2, correct? Is it 2 we are getting? 2 into 10 I think, correct? 2 meter per second. Am I right? What we are getting here? See here, sorry, the initial velocity the given is not 1, correct? 1 meter per second, 1.0, 1 meter per second. So the answer what we get here, it is not 10, 1 square, correct? So the answer what we get here is VF is equal to 2 meter per second. 2 meter per second. Therefore, using the concept of equation of continuity, I can say VA is equal to constant, V1 A1 is equal to V2 A2. See here, velocity of the initial is 1 meter per second, final is 2 meters per second. So velocity of final is twice that of the initial, correct? Velocity of final is equal to twice that of the initial. Therefore, I can say, since it is twice, see here, V is inversely proportional to area. As velocity is increased by 2 times, what you can say is area decreases. As velocity increases, area decreases. So as V increases 2 times, area will decrease by half. So half of the original area it will be. See, velocity is inversely proportional to area. As velocity increases, as area increases, velocity should decrease. Now velocity is increased by 2 times. Then area should decrease by half. So total area will be, what was the original area they have given? Tap area of cross section is 10 to the power minus 4 meter square was the area. Now it is half of this one. Directly, no solving. Directly we can say area is half because velocity is inversely proportional to area. Then I can say 0.5 into 10 to the power minus 4 meter square. Are we having that option? Are we having that option? No. 5 into 10 to the power minus 4 is there. So I can write 5 into 10 to the power minus 5 meter square. Do we have that option? Yes. C is the answer. So answer is C. Next. Next question is 24th question. It is what? Can you help me for the 24th question? The level of water in a tank is 5 meter high. Okay. 5 meter height. A small hole is of area 1 centimeter square is made at bottom of the tank. Rate of leakage. So I can say rate of leakage is equal to AV, area into velocity, correct? The small area of that one with the velocity what it moves is nothing but rate of leakage. That is equal to area into what is the value of V? V is nothing but square root of 2GH. Area into square root of 2GH. So I can say area into, substitute the values. What is the area of area? 1 centimeter square. So I can say 10 to the power minus 4 meter square. Correct? Square root of 2 into 10 into H 5. 10 to the power minus 4 square root of 10 5s are 50, 52s are 100. So 10 into 10 to the power minus 4 is the rate of leakage. Directly it has given, so 10 to the power minus 3. What is the unit? Meter cube per second. Because area into velocity it is. So meter per second. Meter cube by second. Option A. Option A. Next. Water flows. 25th one. Water flows through a frictionless duct with the cross-section area, cross-section varying as shown figure in the figure. Pressure P at the points along the axis is represented by, axis is T. So according to Bernoulli's principle, what we can say? See, according to Bernoulli's principle, as area decreases, volume decreases, then pressure also should decrease, correct? According to Bernoulli's principle, what we can say? As area decreases, volume should decrease, then pressure also will decrease. Water flows in a frictionless duct. Even though water is flowing in a frictionless duct, as the time moves, pressure will decrease. Whatever it is, as the time passes, pressure will decrease. Option A. 26th one. On mixing salt in water, the surface tension of water will increase. The impurities added will increase the surface tension. So option A. Twenty-seventh one. Now, can you help me 27th one? A soap bubble is blown with the mechanical pump at a mouth. The pump reduces a constant increase per minute in radius of the bubble, irrespective of the internal pressure. The graph of the excess pressure inside the soap bubble and time t is. See there, for a soap bubble, pressure is equal to what we have wrote, 4T by R, correct? So, pressure is inversely proportional to R, radius. So, as radius decreases, see the diagram they have given? Here the radius was more. When here comes here, the radius decreased. So, as R decreases, pressure should increase. Pressure should increase, correct? As R decreases with the time, pressure should increase. So, how the graph should be? How the graph will be? As the radius decreases with the time, pressure with respect to time will increase. Now help me. The graph is first one, A. Earlier radius was more, so the pressure decreased. Next. As radius increased, pressure decreases. Why? Because, you are blowing from this side, correct? Radius, initially the radius was less, then radius increased. As radius increases, pressure decreases. So the graph is like this. Understood? You are blowing from this side. So option A. Next, 28th one. How many of you solved this? Two capillary tubes P and Q are dipped in water. The height of the water level in the capillary is 2/3 to the height Q capillary. The ratio of their diameters is, see, radius of the capillary tube is inversely proportional to height. You should know this. Radius of the capillary tube is inversely proportional to height. So, as the height increases, radius decreases, or as the radius increases, height of the liquid rising in the capillary will decrease. So, now, height of the water level is 2/3. Height is 2/3. Then, radius of their diameter is, ratio of their diameter is, can you help me for the ratio of their diameter? RP by RQ is equal to HQ by HP. Correct? HQ by HP. How to solve this? HQ by HP. What is the height they have given? They have given height is 2/3. Correct? HQ, height of the level in capillary is 2/3 to HP is equal to, they have given HP is equal to 2/3 of HQ. So therefore RP by RQ is equal to HQ by 2/3 HQ. So answer is 3/2. Option B. Option B. Twenty-ninth one. Three liquids equal masses are taken in three identical cubical vessels A, B and C. Their densities are rho A, rho B and rho C. Force exerted by liquid on the basis of cubical vessel is, what is the force? Densities are different but masses are same, correct? Equal mass. So therefore force is not depending upon the density, it is depending upon the mass. Now mass is same, so therefore force of A is equal to force of B is equal to force on C. Therefore option C. The same in all the vessels. Force is same in all the vessels. Last question. How to solve the last question? Very easy one. Terminal velocity. Direct question. Terminal velocity is equal to 2 by 9 r square rho minus sigma g by eta. Correct? They have given 2 raindrops of same radius. R is same. With the terminal velocity V, merge from the bigger drop of radius, capital letter R, with the terminal velocity of the bigger drop. See, drops are of same material, so same rho and sigma, g, eta, everything is constant. So V of small drop divided by V of bigger drop is equal to R of small drop by R, that is bigger drop, correct? Therefore, of smaller drop is equal to terminal velocity of the smaller drop or bigger drop they have asked, correct? Terminal velocity of the bigger drop is equal to cross multiply R into velocity of the smaller drop divided by of the small drop is small letter V, correct? I'm sorry, this is square. So therefore R square by R square into V, that is option B. See here, they are of the same material, so rho and density are same. Acceleration due to gravity is same for small drop and big drop. Eta is also same for small drop and big drop. So I can say terminal velocity is depending upon the R square. Using this concept for the small drop and bigger drop, if you divide, you will get this. Then cross multiply. Therefore option B. Yes, this paper was not that difficult. I think it was easy. I hope everyone solved, learn properly, do well in your CET. All the best. Okay? Thank you.